Okay, today we're going to be doing the inverse of non-linear functions, and we've learned how to graph all of these functions in here. Right, this is going to be a parabola. The only thing we really haven't done much of is see a restriction. So this right here is a restriction. This means when you graph y equals x squared or f of x equals x squared, you're only using x's that are starting at 0 and greater than. So if I were to make a table,
0, 1, 2, 3, 4.
So I'm using only x's that are 0 and above. I'm using no negative x's. So my y, when I plug it into the equation, I do y is x squared. I'm going to square it, 0, 1, 4, 9. Then I'm going to graph those. So yeah, that's that parent function that we drew 400 times in class. Only graphing positives. So yeah, you might want to draw both sides of the parabola, but this specifically says there is a restriction. You can only graph part of it. Now what we're going to do is we're going to find and graph the inverse. So since we're doing inverse, go ahead and put in that y equals x line, which always is the same. Always is the same line. It's where 1 equals 1, 2 equals 2, negative 3 equals negative 3. They're always the same order pairs. Same procedure as yesterday, almost. Same procedure as yesterday. How do we find the inverse?
Did you switch the x and y?
Well, there's no y.
But like, I'm talking about like on your graph that you made.
No, how do we find the equation?
You want the equation, you put y in for f of x.
Okay, y in for f of x.
Then you switch it.
Then we switch x and y.
Then square root.
And then we
equals
solve it
square
for
root
y. So we're going to square root. What happens if we square root?
Plus or minus.
And then we put it back into function form.
Include the lockdown drill. Students, remember, if you are in the restroom or you have to not get into the room, the teacher will open the door for you as the lockdown is in place. So make sure you know the situation, bunker down the bathroom where you're at, or escape the building if that is what is needed. If you haven't heard gunshots or something, go away from those, get out of the building. D is for evacuate. We also have several rooms without windows covered. So we need to make sure we'll deal with that and I'll function individually. Overall, it was a pretty good job. Thank you and have a great day.
Okay. So now we've solved for the inverse. And to graph it, you can either graph using the equation or what Jarrett said earlier is just switch the x and the y. Don't take it out on us. Switch the x and the y. So my inverse ordered pairs are going to be 0, 0, 1, 1, then what?
4, 2.
4, 2, 9, 3. So I'm going to graph those.
I'll just look at it. Whoa.
That's where I use my two colors so we can see the difference between my regular function and my inverse function, so you can organize.
So where's the plus minus?
Okay, that's what we're going to talk about now. Yeah. You don't have the notes. Okay. So now what I want us to do is I want us to graph both equations on our calculator so we can kind of make sure that we have it right. So on your graphing calculator, let's graph the two functions. Unfortunately, you can't, well, there's probably a way I don't know how to do the restriction part on the calculator. So just graph the x squared, but only look at the part that we graphed. stuff here. I liked how he came in and he was like, I got my calculator. No, you didn't. Graph both of them. So the inverse also. Equals, and then you switch them. So you divide by negative and get square root it. So what happens when you square root it? Okay. And that's what we're talking about. We're about to talk about that. All right, who's got it graphed in color so I can borrow yours?
I has no color.
Not 100%.
Yeah.
You're like 75%.
Hey, it's.
No,
it's
75% of it.
Task.
Actually, technically, you guys are right. The ones I just said were 75% of it. But I'm looking for somebody who has all of it graphed.
I do.
Okay. Right here. This is all of it graphed. But this really isn't what our graph looks like. Remember, our graph is just the first quadrant?
Yeah, calculate as well.
No, it's not. It's because when we did that square root and we put in the plus minus, there was originally a restriction that was saying only to use half of it. So we really only are supposed to use half of it. So when you look at this calculator, she's got a red line on top and a black line on the bottom. Which half is the correct half?
Red line.
The red line. So when I look at her y equals, the red one is just the positive one. And that kind of makes sense. If you think about the equation, we only use positive numbers, and only positives you can take the square root of. So even though you are supposed to do plus or minus, our final answer is only the plus part. That's our final answer for the inverse.
You reflect it over the y equals x line.
Right, so I'm going to get rid of her minus. I'm going to hit graph again, and you can see, now this one we just have to know that it's only that half. So I'm going to cover up the other part that's not it. You can see that it is an inverse function. Okay, so we kind of have to think about it for some of these. Now what we have next, is determining if it is a function. And a function is just a label that we talked about a long time ago. Long time ago, a function is just a kind of equation where the x's never repeat. Like every single x only happens once. And we could determine if something is a function by using what's called a vertical line test. So here's some crazy graphs. If I take a vertical line,
And it intersects.
if it intersects more than once, then it's not a function. So is my first one a function or not a function?
Function.
What is a function? How about my second one?
Not a.
Not function.
Not a.
And that's because it intersects more than once with the vertical line. So we did that a long time ago. What this is in our notes is to determine if the inverse of the function is also a function, if it has that same title. You can see that this first graph is a function if you use the vertical line test. This one is a function, but is the inverse a function? To tell if the inverse is a function or not a function, you use the horizontal line test. You go the other way.
Oh, really?
So is the inverse a function?
Is that the inverse?
No, this is the function. But you can tell if the inverse is a function without actually graphing the inverse by using the horizontal line test. So the vertical line test is for the function, the horizontal line test is for its inverse. Is the inverse of this a function? Yes. Is the inverse of this one a function? No. So it's just really a yes or no question. We're going to use our graphing calculator to help us go a little faster to determine if the inverse is a function or not. So f of x equals 2x cubed plus 1. Let's type that into our graphing calculator. Y equals 2x cubed plus 1. Go ahead and graph that. And the question is, this is a function, because it says f of x, this is a function. The question is the inverse also a function? So we're going to use the horizontal line test. Can I borrow some calculator? Sometimes I feel like
It's just disrespectful.
sometimes I feel like I live with my, not live, but I work with my children and live with them. My children are 5 and 6.
Do they leave crayons on the ground?
Actually, yeah, but I don't usually step on them because I'm aware of it at home. I stepped on a crayon, by the way. That's what I'm doing.
Yeah, I was like, what are you doing?
Yeah. Some people can see.
I got a front row seat.
Yeah. You're recording it too? Okay. There we go. So we take this and we get a horizontal line. Does the horizontal line pass more than once? The graph passed more than once through the horizontal line in this case. Yes or no?
Yep.
Okay. So is the inverse a function? If it only passes
Yeah.
once, the answer is yes.
Yeah.
So yes is our first part. Yes, inverse is a function.
How are you doing the fun?
So yes, the inverse is a function. Now we are going to find the inverse. Same stuff we did yesterday. First, switch x and y. Then solve for y. So how do I solve for y? Take away 1. After I take away 1, divide by 2. And then what do? Cube root. Do I need plus or minus?
No.
Yay. Now I want you to graph, GVEX. Then I want you to graph both of them on the same window. This one doesn't have any restrictions either.
So grab both of them?
Grabbing both, yeah, like Y1 and Y2. So you got plus on, up, hit enter.
You're gonna have to graph it in three.
Guess what? Guess what? Guess what? Come on.
Somebody who has a color and has both of them graphed?
T.
Yeah. So, if yours does not look like that, type something in wrong? Or maybe your windows, your text is off.
See that? It's like that.
No, I was gonna take it.
Oh, these crayons are made of China. They're non-toxic, so I can.
Okay, so if I drew in my y equals x line, ooh, actually, we can put in the y equals x line. Go to y equals.
Y equals X.
Yeah, make one of them y equals x. There.
So complicated.
Can you even draw it?